Okay, welcome back. Hopefully you gave it a try. Let's see what I get. Okay, so first thing I'm going to do is take the natural log of both sides. So ln y is equal to ln x to the power of cos x. Then I'm going to use my exponent rules, and I'm going to bring that cos x down the front. That's the power rule, and that results in a product. So we will use our product rule to differentiate this. So the derivative of ln y is 1 on y prime. You might just get into the habit, and perhaps you've already been doing this, y prime on y is equal to, so 1, which is cos x, d2, 1 on x, plus 2 ln x, d1, negative sine x. All right, so there's our little rule. And what could we do to tidy any of this up? I'm not feeling there's much of anything. I always say if you can tidy it up before you move on to something else, that's always helpful. Minus sine x ln x minus ln x sine x. I don't know. I guess I should stick with the ln in the front. I don't think it matters. It doesn't matter. They're a product. Okay. So what's left? Just to multiply that y. That's it. This one was super fast and easy, hopefully. Let's see. So step 4, we have that y prime is equal to, so who was y? Y was x to the power of cos x, and then we have cos x on x minus ln x sine x. And really, there's not anything we can do to make that prettier. I guess if you wanted to make a common denominator of x on that, last term, it's not necessary. You certainly could, though, if that made you happy. So we would have cos x minus x ln x sine x. That's a lot of x's. And then the whole thing could go over x. I wouldn't, if I was marking a question like this, I wouldn't mark it incorrectly. We don't want you to do a ton of work trying to make everything look pretty in these questions, because that's kind of defeats the purpose of using this method. The method is to simplify taking the derivative and the work that's required. All right, so basically that's the end of chapter 8. And there are just 4 cases for exponents and bases that we've looked at. And so you just a quick recap of stuff we've looked at between chapter 2 and chapter 8. Okay, so chapter 2, if you're asked to take the derivative of a number to a power of a number, just remember that that's, if a and b are both constants, it's just going to give you a 0 answer for the derivative. So this is saying, something like 5 cubed. Well, 5 cubed is 125. What's the derivative of that? That's 0. Then the second one we looked at was the power rule from our polynomial function, right? So if you had, 3x squared, right? So then you would have that the derivative is 6x, okay? But should you have something more funky inside your function, then you have the chain part to it, okay? So let's say we had 3x squared plus 7x raised to the power of 4, right? So then this was bring down the 4, leave the inside, that's the f of x, reduce by 1, and then take the derivative of the inside. So 6x plus 7. Okay, so that's stuff that we learned in chapter 2. And then in chapter 8, in 8.2, we learned if we have something raised, 5 raised to the power of 2x, then the derivative of that is actually 5 to the power of 2x ln 5, and then the derivative of the exponent, which was 2. We also had the unique case of e, right? E to the x's derivative is just e to the x. And then lastly, the one that we just saw is what happens if you have something raised, a variable raised to a variable. Okay, whereas number 3 is a number raised to an exponent with a variable. Number 4 has variables in 2 spots. So those are the 4 exponential and base kind of sampling cases that we saw in this course. And then down below is just a summary of the differentiation formulas that we looked at in chapter 8. So e to the power of a function, this is the same as e to the power of u, right? And then du dx. I like the u's better than the f of x, but maybe you like that one better. And then if you have something other than e as a base, right? So just pay attention if you have something other than that. B to the power of u's derivative will be b to the power of u ln b. There's that extra piece. And then the derivative of the exponent on that, okay? And that's just because in the e case, if we had ln e is just 1. So it's going to cancel itself out. Whereas ln 10 or ln 7 or ln 4, that's a funky number, okay? All right, so that was from the exponential piece. These guys would have been coming out at 8.2 mostly, and then this would have been our 8.4. So what do we get for logarithmic, right? So this, we've got exponential, and on this side, we've got what we did with the logarithmic. So the derivative of ln u is 1 on u du dx, right? And then just be careful if it's log of a base b instead of log of base e. That's it. That's the end. I don't have anything more to say other than congratulations. If you made it this far, that's amazing. And I wish you all the best. I wish you guys all the best. Wish I could give you guys hugs. But you know, that's all good. We will see you again soon. One day, I'm sure.